This is Chapter 3 on Exponents. This is your practice test. You have 21 questions. We'll go through them one at a time. If you have any questions, make sure you ask me prior to next class, which is going to be Tuesday. Second period is your test. So the first question says true or false. Is this equal to -4? And the answer is true, and here's why. When you have any negative power, there is a difference between these two questions. There's not a difference between the standard form. Actually, I'll put a square there. Make it. So when you have these two here like this, oh, sorry. This means the opposite of, or the negative value of, or the opposite value of, and then this is the power. So the power is actually 4 squared. So since 4 squared is 16, the negative value, that would be -16. When you put brackets around the base, this is different. It changes the value of it altogether. Because when you put brackets around the base, it says, please use this in repeated multiplication. So it would be -4 multiplied by itself twice to give you +16. In repeated multiplication, this would be the negative value of 4 times 4. So if you look at them in repeated multiplication, it makes sense. So back to this one. This is the negative value of 2 times 2. And this is just -4. They are the same value, so therefore it's true. The next question says in brackets -5. So this means this is the base, and our exponent is 0, has the same value as -1. And this answer is false. And here's why. So if you have any base, whether it's negative or positive or whatever you want, to an exponent of 0, the answer will always be 1. Because if you use your rules, so if I was to divide these two and think about what this would be, this would be -5, so I would keep the base, because I'm dividing like powers, keep the base and subtract your exponents, that's our law, and you would have -5 in brackets to the exponent of 0. If we examine this in standard form, it would be -20 or 25 divided by itself, which is 25, and we know any number divided by itself is 1, so therefore any base to the exponent of 0 will always result in 1 because you'll be dividing itself by that. The only exception is, and I'll do it in red ink, this does not equal 1, okay? This does not equal 1 because your base is not -5. Your base here, your base is really 5, not -5, because the brackets are not around the -5 to say it's the base. So if there are no brackets around it, the base would just be the number itself. So in this case, it's base 5. So this would be the opposite value of 5 to the 0. Since any base to the exponent of 0 is 1, this would have a -1 value because it's not in brackets. I know that's complex, and I know it's kind of hard to wrap your brain around. But if you just remember brackets around a number that's the base, means it's used in repeated multiplication. And if it's no bracket around it, it is not a part of the base. Question 3, we have this. Now this is one of those tricky ones, because if you listen to what I just said, it seems like the -2 is in brackets, but the -2 is not in brackets. And what I mean to say by that is this is not the same thing as this. Okay, here the entire power is in brackets, which does not mean the base is -2. Here the brackets are around the -2, which means your base is -2. So this is really the same thing as this, because they are, the only difference between them is the brackets, right? So therefore this question here, they're the same thing, so therefore it's true. If the question was this, is that true? No, that would be false, because the brackets are around the base, which is totally different than the brackets around the entire power. Question 4, -10 in brackets, that's your base, cubed, is greater than or equal to -30. Well, this is a pretty easy question, because -10 cubed, if we were to simplify that to a number, we would have -1,000. and over here is negative 30. Is negative 1,000 greater than or equal to negative 30? No. Negative 1,000 is a lot less than negative 30. So your answer for this one is false. It is not greater than. It is less than. Owing $1,000 versus owing $30, you're richer if you only owe 30. Question 5. So here we have two powers that we're dividing, and it says this is going to be equal to positive 16. So if we follow our laws of powers, if we're dividing them, we keep the base and subtract the exponents. So exponentially, what I would get is negative 4 in brackets to the exponent of 2, which in standard form is 16, and therefore the answer will be true. They are the same thing. Question 6 is in the expression negative 5 squared. The coefficient is negative 5. Well, the word coefficient, when we learned it in algebra, is really a multiplier for the expression, And this negative sign here is really multiplying this expression by what we call that invisible negative 1. So the coefficient in this one is actually negative 1, not negative 5. So the answer is false. It's negative 1. In question 7, we have 5 plus 2 in brackets to the exponent of 3. And if I could do arrows, I would have done something like this. Is the same thing as 5 cubed plus 2 cubed. And it appears that this is using one of our exponent laws, that when you have an expression in brackets to an exponent, you can distribute that exponent to all of the terms inside the bracket. But the reality is this is false. And the reason why is the only time you can distribute them is if you have multiplication or if you have division. You can distribute them because this would be the same thing as 120. I won't simplify it. But you could work it out and it works out well. Here, if we were to do this, this would be 125 and this would be 8. And 125 plus 8 is 133. And if I was to take 7 and cube it, which would be the same thing if I simplified the brackets, 7 cubed, wait, calculator over. 7xy3 is actually 343, not 133. So the answer is false for that. Question 8, negative 2 in brackets to the exponent of 0 plus negative 2 in brackets to the exponent of 0 inside is equal to 0. Well, this is the base, and any base to the exponent of 0 is 1. But this one is actually the same thing as this one. And in this particular case, the base is not negative 2, the base is 2. 2 to the 0, or any base to the 0, is 1. So the negative value of that would be negative 1. So 1 plus negative 1 does equal 0, and therefore that's a true expression. True question. True dat. Question 9, it says, on your sheet I copied it down wrong. It should have read this. Apparently I did 5 fours, or I should have only had 4 fours. So true or false, does this equal this? And the answer is true. Because this here is 4 to the power of 4. And I'm multiplying that by itself twice, which really means exponent of 2. So really, if I thought about what this would be, our exponent laws say keep the base and multiply the exponents. So here we would have 4 multiplied by itself 8 times, which if I add these up, 4 and 4, it would be 8. So if you got that wrong, it's okay because I just misprinted it. I got to change it. Question 10 says negative 5 times negative 5 times negative 5 times negative 5 is equal to negative 5 in brackets to the exponent of 4. The answer is false. And what it should be equal to is negative 5 in brackets to the exponent of 4, not negative 5 to the exponent of 4 in brackets altogether. Because this is your base. That's what's used in repeated multiplication, not the entire power. Question 11 says, what is the missing exponent? So we have 10 to the exponent of a square times 10 to the cube, and it equals 10 squared. Well, we know the exponent laws say when you have the same base, you can keep the base and add the exponent. So this plus this equals this. So what number does this have to be? It has to be negative 1. And we said yesterday, just for poops and giggles, that if you have a negative exponent, this negative here actually means this, and the rest go underneath there. So 10 to the negative 1 is technically just a tenth. You don't have to know that last part. Question 12, we have 10 to the square divided by 10 to the exponent of 3 equals 10 to the 4. Now our laws say keep the base and subtract our exponents. So what number take away 3 is 4? The answer is 7. So it's 10 to the 7th, or 10 million. Question 13 says negative 10 to the 4th, evaluate it. Well, that would be negative 10 times negative 10 times negative 10 times negative 10. We know that when we have a negative base to an even exponent, our answer is going to be positive. So 10, 100, 1,000, 10,000. Our answer is positive 10,000. Sometimes it's easier just to write your 1 and then write this many zeros, and you get the answer a lot easier. Question 14, evaluate negative 2 in brackets to the exponent of 2 plus negative 5 in brackets to the exponent of 2. So we have this in repeated multiplication. Negative 2 squared is 4. Negative 5 squared is 25. So when I evaluate it, the expression is worth 29. Question 15. 10 take away 6 in brackets to the exponent of 2 plus negative 3 cubed. Now, if you try to distribute this, that would be a wrong idea because you can't distribute exponents to subtraction or addition, only multiplication and division. So here you'd have to simplify it to be 4 squared plus, I've got to simplify this now, this is going to be negative 27. It's going to be 16 plus negative 27, which is going to end up being negative 11. Is that right? Negative 11. Question 16. The opposite of 5 squared plus 10 to the 0. The opposite of 5 squared is not negative 5 times negative 5. It's, since 5 squared is 25, the opposite of that will be negative 25. Any base to an exponent of 0 is 1. So when we simplify the exponents, we get negative 25 plus 1, which is negative 24. How many got that wrong? A few people. Easy mistake to make. Question 17 says 1 to the 5th, take away negative 2 cubed, multiplied by the square root of 16. 1 to the 5th would be 1 times 1 times 1 times 1 times 1, which is still going to be 1. Take away negative 2 cubed is negative 8, multiplied by the square root of 16, which is 4. Don't forget to do order of operations, so this is still going to be negative 1 take away. The product is what I do first, which is negative 32. Important you keep that in brackets. Keep flip change. When you subtract integers, you get 33 as your answer. Question 18 is the negative value of negative 2 squared to the 5. Okay, so let's work on this. Let's see what this looks like. So there's two ways you could do it. You could simplify the brackets, or you could put your exponent to the exponent, which would be the opposite of negative 2 to the 10, because your law would say keep the base and multiply your exponents. This is going to be the opposite of 2, 4, so let's see what 2 to the 10 is. I think that's 2 to the exponent of 10 would be 2 to the exponent of 10. It's 1024. Since it's an even exponent to a negative base, it's going to be a positive 1024. That's what it would look like next. The opposite of that would be negative 1024. And now we apply this one. The opposite of that is simply 1024. So when you do all the rigmaroles with all those opposites, you end up getting a positive 1024. Question 19, a lot of people were confused by it. It said 5 to the exponent of 4 multiplied by 2 to the exponent of 4, right, using only one exponent. Well, here we have that idea of having in brackets this And if I put the one exponent here, these two things are the same thing because I could distribute the exponent to each term and have this. So my answer is this here. 5 times 2 to the exponent of 4. Question 20 says using a formula to determine the volume. So the volume is area of the base times the height of the prism. So here's our thing here. So the area of the base will be a circle multiplied by the height. So the formula we're going to use is pi r squared h. Pi we're going to just treat as 3 because we want to be able to do it without a calculator. The radius would be half of the diameter, which would be 3. And the height will be 15. So when we substitute it all in, that's what it looks like. Really, we're just asked if you're given the formula like this, do you know to do exponents first? Yes. So I do that. Then I do this. And 27 times 15 is 270 plus 135, which is 405. 405 centimeters cubed is the volume. Formula, substitute, simplify, answer. And the last question is, Mr. McDonald's coffee mug has coffee in it that's molding. It has 1,000 bacterium. So if I put down N for the number of bacterium, sorry, N is going to go over here. And T for time in hours. I think hours, is it? Or weeks? Weeks. So if there was 0 weeks gone by, there would still be 1,000 bacterium in my coffee mug. After 1 week, it would double. After 2 weeks, it would double again. 3 weeks, double. 4 weeks, double. 5, 6, 7, and finally 8 weeks. Did I make a mistake somewhere? 256,000, is that right? So after 8 weeks, you would have 256,000 bacterium, I think. Is that what I got? Is that what you got, Devin? Yeah, okay, perfect. So it says, then what would a formula be for that? So remember, we have a formula for bacteria. You're going to have this question on the test, so please make sure you have this down. Starting number is your coefficient. So in this case, 1,000 bacterium will be our coefficient. Inside the brackets, you're going to put the rate of growth, whether it be doubling, tripling, quadrupling, etc. So in this case, we are doubling, so we're going to have an exponent of 2. And the exponent up here goes the units of time. So in this case, we're dealing with, it doubles every week, so our units of time are going to be t up here. Okay? So in this case, if I was to substitute the information and I wanted 8 weeks, I would simply have 1,000 starting bacterium, doubling, and it's going to be 8 as my exponent. I would simplify it to be 1,000 times 256, which is what 2 to the power of 8 is, and therefore I'd have 256,000 without having to make a table. I could simplify it. So if I asked you how long would it be if it did a year, well, we'd put 52 up there because there's 52 weeks in a year. 2 to the 52 is a large number, but we'll just see what it says on the calculator. It is 4 million, billion, trillion. Did we say quadrillion? 4 quadrillion, but then we have to multiply it by 1,000. So we'd end up with 4 quintillion, 503 quadrillion, 599 trillion, 627 billion, 370,496,000 bacterium in Mr. McDonald's coffee mug. That's a lot. That's after a year, 52 weeks. Okay.